Thanks again for coming. Good afternoon. Yeah, this time is really afternoon. I hope you had a good meal, and you're well rested to digest what's coming up. Uh, this talk is absolutely brand new. Right, I just finished that talk last night, actually 5 minutes ago. Um, the, I noticed something I need to debug at some point, but let's see. It's the fun of new things. Also, as of this afternoon, I'm not anymore technical evangelist. I'm a cloud architecture technical evangelist. That happened, so it's cool. But so a lot of things happen. This talk is going to be about a lot of different things, a lot of different services coming together. But as I said, it's going to be also focused on availability and reliability, really understanding those concepts and why people go into building multi-regions active things, which has been made popular. Actually started 2013, where the first workloads active on AWS. How many of you know Netflix? Yeah, that's what I thought. So that topic, active multi-region, has been made popular by Netflix, and I'll talk about it a little bit. But the objectives of that session is really to understand what is reliability and availability. I think a lot of people talk about it, but not necessarily understand the ins and outs of it, how we talk about it, and how does it affect our services. What are the famous nines of availability? What does it mean? How do we calculate those stuff? Why do we go into building multi-regions active architecture? Right? It's not something that, or at least it's not something that used to be very easy, yet people have gone towards it for a long time. The first known reference use case was 2013, when Netflix wrote their particular blog post about it. We're gonna look how we do it, some of the codes, and especially how we do it serverless style and why serverless. I think we all know now that serverless is embodying the ideas of highly available and reliable services because it sits on top of the 3 AZ things. Then we're gonna look at the demos. I think that's been built. It's code that I'm gonna push soon into GitHub. Probably end of this week, so you'll be able to deploy and play with that stuff, and so hopefully then you can get your hands on it. Let's first talk about system reliability and availability. What does that mean? So the first thing we need to understand is something that I love, that quote from Werner Vogel, is that failures are a given because everything eventually will fail. So you can think about failures as things that you try to avoid, or you can embrace them. There's two choices. Right? Trying to avoid it is just gonna work for a certain amount of time. Eventually, you're gonna hit a failure. Right? So if you embrace them and design around them, that's the best way to juggle. That's the best way to understand and actually make it your friend. Understand failure and play with it instead of avoiding it. That's really, in the 10 years I've worked with AWS, that's the most important thing that basically had to come out of those 10 years, is embrace failures. And then tons of things that you can do for that, and we'll talk about it a little bit there. Chaos engineering being one of those. So when we talk about system failures, and especially the rate of the system failures, there's 4 different ones. The fourth being the sum of everything, but ones are the early failures, the one that you see in this yellow graph. Note for the futures, I need to separate those graphs. It makes it easy to see. But the yellow one, early failures, your probability to have failures at the beginning is higher as your system age. Those early failures are slowly fading away. There's a few reasons for that. Those are the early bugs, the operational routines that come in place, people setting good practices. So all those early bugs are moving away. The second one is the one in blue, in green, this one, which we call the wear out failure. So it's like for any components or any systems, as it ages, there's more failures rate that happens. Right? If you have a hard drive and you buy it, now you have probably in 3-4 years, higher percentage or the rate of it failing is just going to happen. So as your system age, there are different failures coming into place. The red one is random, and those happen all the time. Whether it's a squirrel eating the cable, whether it's a truck driver hitting the electric pole at the entrance of your data center, whether it's lightning, whether it's a car that jumped through a roof, whatever it is, it will happen. Anything eventually happens over time is statistical, right? So that's why it's very important to understand failures, right? Because if you only plan to ditch the early failures, so minimize bugs, minimize those things, which is great, over time you still will have some failures, right? So when you talk about observed failures in systems, they are like this, what we call like the ball, right? So very important to understand that, because it totally dictates the way you're gonna play or orchestrate your teams, right? And the way you distribute software as well. And to go with that, at AWS we launched something called the well-architected framework. And one of those pillars, which is reliability, only talks about that. And this is why it's very important to understand what reliability is, because when you orchestrate application on top of the cloud, reliability is prime thing to do, right? It's super important to make sure your system is reliable, that it can respond to random failures, that it can recover automatically. Otherwise, your customers are just gonna complain and not be happy. So what is reliability? There are three things really that encompass reliability. The first one is the infrastructure and service disruption, being able to recover from those. And this is the classic one. So, an availability zone having some networking issue, database having some problems, all this kind of stuff. How do you architect? How do you think about architectures with that in mind? And very often we look at those as what are the points of failures, right, in the systems? What are the systems that if this goes down, for example, if in my architecture I have a load balancer, all of a sudden if I take it out, what happens? Because that can happen, right? Chaos can just decide that that load balancer will stop working. Does it have an effect on your entire application? Does it have a cascading effect on other load balancers that all of a sudden get the traffic? So this is what we call the infrastructure and service disruption. The second is the ability for your system to recover from that, especially to get the computing resources required to support your demand. So as your user grow, how does your system grow? Does your database grow faster than your load balancer? Does your application scale out? Does it scale up? All of these things, right? And these are usually done by load testing. Simply a very simple way of doing that is understanding how do you load test your application. Is your application memory bound? Is it CPU bound? Or is it memory bound for the first 1,000 users and all of a sudden it becomes CPU bound once you have 2,000 users? Because that can happen. The component dependencies, software dependencies are so important nowadays that it's very difficult to understand what are your requirements in terms of applications. So this is very important to understand the number of users that can be supported by the platform. All these questions are super important. And finally, how do you mitigate disruptions? And especially, how do you mitigate misconfigurations? Because that's happen. Once you start to have 200 microservices, you have, across a period of 3 or 4 years, a big chance that you're going to have misconfiguration. So what do you do out of it? So these are the questions and the things that are really important to have in mind. And this is why I love reliability, because all of a sudden you think about architecture in a totally different way. Couple of things that are very important to understand when you talk about reliability is what's your system availability. And just to give you an idea of what is availability, and I'll start at 95 because I think in the industry it's pretty much if you're below 95 you're not serious anymore, right? That means that if at the age of cloud you can't achieve to have less than 18 days of downtime, there is something wrong, right? So, but not everything has to have 99.999% availability, right? Not at all. And this also has a big impact to understand what it really means, because a lot of customers all of a sudden start to say, oh, I want to have 4 nines of availability for 52 minutes in 1 year of downtime, right? And you can understand the impact it has on your operation, right? How you're gonna orchestrate, how you're gonna lead the operation. So this is something that is critical to understand when we talk about reliability. What is it that you're trying to achieve? Do you want to be offline 31 seconds? There are customers that are 31 seconds per year downtime. But that means that everything is automated, right? Everything is active, automated detection. It's insane, right? It doesn't mean you have 100 people, right? We have teams that are below 50 people that actually achieve 31 seconds of downtime a year. It's not impossible at all, right? And I put this because this is actually true. It's the way my loved one wants me to answer. Is every 35 seconds if I don't go there. That's the way it is. But if you think about bank transaction, this is where we are, right? Banks need to have 5 nines of availability. That means a year they need to be 5 minutes down. So this is something that is really critical to understand. And most of the time when I work with customers or teams in my previous companies, and we had that in front of us, it really changes the way we design applications, right? So important to understand. And there's a very good cheat there that you can use. There is the link there. The second thing is, in a system, we have series, right? So for example, you have an architecture or a system that is with 2 components, X and Y here. Now understand how they affect each other, right? Now if I would tell you that if actually X is lower than Y, the overall availability of the system is going to be lower than X, right? That's mathematics. In fact, that's the way it is, right? If your component X is 99% available, and if Y is 99.99, then the overall availability of the system is actually lower than the component X. This is something that is not necessarily, doesn't come, right? We always say a chain is as strong as the weakest link. There, the chain is actually weaker than the weakest link. This is something that is important to understand. Second is when you have systems in parallel, right? If you have 2 components in parallel, that actually increases availability dramatically. And this is super important to understand. So for example, if I have X is 99, if I put 2X in parallel, all of a sudden I go from 3 days, 15 hours of downtime to 52 minutes without changing anything in A, just by putting it in parallel. I don't know, when I see those numbers, even though I know them, it's always like mind-blowing for me, right? It's like, well, that's as simple as that. And if you put them 3 times, all of a sudden you have 6 nines of availability, right? So that's the way it is, right? So it's super important to understand how you do that. Now, if you combine this with series and parallels, of course the overall system is affected, but this is important to have in mind. And it's very important also to understand it's not the only way to measure availability. You can measure availability by dividing the normal operation time, what we call the mean time between failures, so the time where you actually operate the system over the total time, which is the mean time to failure plus the time to repair. So when you want to give an SLA to a customer, this is what you need to understand, right? And that means that if your mean to repair is 52 seconds, you better have the good operations and automation in place to support that, right? So this is very important. So overall, what we can say is that the component redundancy increases availability significantly. And this is one thing we really need to to remember. And it's at the base of how we design regions, right? I'll again talk about this now, but I talked about it previously when we talk about regional service like S3, Lambda, API Gateway, DynamoDB, Athena. All those they are architected over 3 or more availability zones, right? So that means that they are extremely reliable and available. And that's also the way you should design your application, right? Because if my application is just spreading across several AZs, all of a sudden I have the parallel availability mathematic that comes in and kick in, right? And it works for me. So those are the regional services that are really, really important to keep in mind when you design global systems, because those are the ones that will help you achieve the high level availability that you're looking for. You see here, I put them in there. It's simply that they are not by default, but you can enable multi-AZ support for RDS, for example, right? You can enable that as well for Elastic Cache and Elasticsearch. So those are interesting service when you're going to use to keep in mind. And this is, again, I'm going back to this slide, but for me, that's when we talk about serverless. Why I'm really interested in having multi-region active applications serverless is because I'm not going to have to worry about that. That means that I don't have to worry that all my database that I manage myself. 10 years ago, I had the replication, the bin logs replicated to all the regions, all this kind of stuff. I don't have to do that anymore. The systems does it for me, right? So I can focus on my business logic. And this is what it really means, right? A regional service, by default, they are orchestrated like this. Right. So that means we all of a sudden get the parallel availability there. And if you look at our global region span, it's currently 18 regions, right? We're 4 to come, and then 50 availability zones, right? So it gives you a fair amount of regions where you can replicate your system, right? And when you do a multi-region active, you don't have to stay at 2 regions, right? You can actually go at, let's say, 4, 5, 6 regions if that's what you're looking for, because it will increase your availability. In fact, I just discussed with Daniel, he was talking about a customer for the insurance company that are doing just that, right? Or design applications and then make them very available for their customers simply by replicating them region and then having that. Now the difficult part of doing that, and especially the difficult part before, was managing data, right? So we're going to look a little bit about this, because when you have regions, you have problems of distances. Another thing what you need to also understand is, with availability increasing, the cost of it is going to increase. And I'm not necessarily only talking in terms of cost of material, not your Lambda function or API gateway. I'm really talking about human cost, right? Because when you want things to repair automatically, you need to work for it. You need to design manuals. You need to have automated procedures. You need to test. You need to have teams to test. You have teams to test the testing teams, all this kind of stuff, right? And these are very important. And if you are interested in reading more about this, really, the chaos engineering methodology is a great way to start. Second thing as well is, with cost increasing, availability increasing, complexity increases, right? And especially back in the days when you wanted to have a global system, the most complex things was reconciliation of data, right? Because if I have customers, global customers, sending banking information, insurance information in region A and then region B, and then there is a difference in the data, how do I reconcile those, right? So took enormous amount of effort, especially in 2013 when Netflix started to work on that, for them to have an active regions, because there was nothing like the systems we can have with serverless today to support what they were wanting to do. Right? So the next question is, why do we want to do that? Right? Because we know it's going to be more expensive, we know it's going to take a lot of work, and we know it's going to take a lot of work. There's few reasons for that. One of the most important reasons is really increasing, improve the latency for your end users, right? Especially when you talk about transaction, right? If you have a user in Asia that is buying things in US, and for every transaction that he's trying to do, you need to go back to the US and to close the transaction, the latency is going to be massive. It can go up to a second, maybe, you don't know. Right? And some systems you can't design with latency more than 300 milliseconds. So just having very small latency gives you a lot more opportunity in terms of what kind of application you can build for your customers, right? You think about financial service, banking, things where the times to the transaction is super important, right? So we are just building a region in Sweden, for example, right? So in Sweden, there's going to be very, very low latency, 1 to 2 milliseconds. And all of a sudden, it opens a lot of use cases into the fintech industry, right? Because then you can compete and in the global market in terms of how fast you can buy things and sell things, right? All these kind of things. But it doesn't mean that your service is going to be limited to Sweden. You can have the same service anywhere else in the world because there are other regions there. But the problem is, how do you reconcile the data? So just to give you an example, the difference in latency if you're here and you try to access a service in US, in Seattle, for example, that would take about 140 milliseconds, right? And then 300 milliseconds for Australia. So it's quite significant, right? Compared to 1 millisecond if it's in the same country, for example, here. If I would access the Swedish region, if it was built already, which it will at the end of the year, it's gonna improve a lot. 1 to 300, it's a massive improvement. The second thing is, of course, disaster recovery, right? And when you use and design an application, there very often are links between services, right? So for example, your application push data into S3, which trigger a Lambda function, which trigger an update to DynamoDB, right? So if a service becomes unavailable, like this, for example, service 4, it doesn't make the region go down, but it makes your application go down. Because all of a sudden you cannot store the data into DynamoDB, right? So this is very good use case to actually move your user to another region. Right? And these are for applications that you don't want to miss transactions. Right? For example, shopping cart, tickets, buying tickets for a concert, all this kind of stuff. Right? You don't want to miss those because of a problem in the network in the region, right? And very often people say, not very often, but I hear quite regularly, oh, region went down. Regions don't usually go down. What goes down is a service that has cascading effect on other things, right? And this is exactly what we're trying to solve by disaster recovery here. And then, of course, business requirements. So we're talking about law compliances and things like this, which sometimes require that you have an active replication. And in particularly in regions like in the US, where you have two regions in the one region in the east and the west, when the data needs to be separated of at least 600 kilometers or something like this for some requirements, which happen. In Europe, it's going to happen as well, because with European law, you can store your data in any part in Europe, some of the data. As I said, Netflix started the whole thing of active for multi-region redundancy. And very interesting thing, what they said very early on is that the failure is function of scale and speed. And what they meant by this is their sole purpose was to go as fast as possible to deliver new features and new service for the customers, very similar to what Amazon is trying to do. That means that the faster you go, the more prone to errors you are. Right? So what they realized is before that is that they were hitting a block, that they couldn't go fast enough because they started to have all those early bugs, early failures that we talked about. So the early failures rate started to increase, and they wanted to remove that. So they moved to a multi-region infrastructure to support their velocity of deploying components to their end users. So they could start to do A/B testing as well at region scale. So deploy features in a region and still have the other region active as a failover. And if all of a sudden a component would go down in their service or wouldn't work as they wanted in region A, they could, in a couple of seconds, shift the entire traffic to another region. Right? And this was something that totally blew people's mind, which is in 2013, right? It's not at the scale of the cloud. It's like prehistoric time. And they still don't stop, right? They made an update to that blog post, which I strongly suggest everyone to look at it. Is that in 2013 they were talking about 2 regions, right? So they had a shift between 2 regions in the US, exactly for the reason I explained. But now they say, well, what if our European customers start to have problems, right? Now they are global companies, so they increase their global resiliency to 3 or 4 regions now. Very interesting read again. And if you're familiar with Netflix, they've kind of, I would say, started a whole new field of engineering, which is called chaos engineering, right? They didn't start, but they made it very popular, right? And what it means by that is they introduce random errors in the systems. And they have a very popular set of monkeys called the Seaman Army that they unleash in their system, in the architectures, to randomly kill stuff, right? So this one kills EC2 instance, this one destroys security groups, the other one destroy networks, and the big king there kills a region, right? So, and those are all open source, so you can all use them, download them. Just be careful. They are really powerful. Use them on test and dev first. Especially not the king one on production environment, can be damaging. That's the next time I'll do this talk. I'll unleash the regional on the demo just to showcase how it works. But I don't have it now today. Sorry. But this is very interesting, and they have a series of blog posts about why they've done all that. So if you're interested about this, you should really read it. So how do we do that? So we know that we need to have regional services that are across AZs, but we also need to understand the problems of data replication. And basically, if I have a component A that tries to replicate to component the same data to component B or C, depending on the distance of that component A to B and C, you're gonna have to switch to a replication mode, right? So what we say in the industry is you cannot have synchronous replication if your latency is bigger than 5 milliseconds, right? And what we say that between AZs, we have usually 1 to 2 milliseconds, right? So that's roughly 10 to 15 kilometers. 5 milliseconds on the internet scale is roughly 50 kilometers, right? So it doesn't give you much. So that means that as soon as you have a distance or latency higher than that, you're going to move to asynchronous systems. Right? That has 2 consequences. That means that you need to design application for being asynchronous, right? And understand that the data that you will, for example, store in A won't be available in C only after 200 milliseconds. But if you talk about transaction, it can be much longer, right? So this is something very important to understand. That also means that you need to sit on a very reliable global network, and the internet is not one of them. So that's why we launched, and that was in 2006, we publicly talked about it, that we announced this global network. This is totally Amazon-based network that is wiring all the regions together. So when you are doing multi-region let's say, architectures, especially using some of the service like S3 cross-region replication or DynamoDB global tables that we're going to talk about, the data doesn't go over the internet. It actually goes through our global network because it pretty much improves latency and packet loss, and we can control that as well. And just to talk about technique, it's actually 100 gig of network cycles around the globe, right? So it's pretty substantial network. We even laid some transoceanic and transatlantic cable just for that. And if you want to read more about this, there's a presentation from James Hamilton, who is this guy, VP, he's here, Vice President, Distinguished Engineer at Amazon, and he had a keynote at reInvent in 2016. Fascinating talk, and not because I'm at Amazon, but just because it's just fascinating. That means that we can now also offer a multi-region, multi-VPC connectivity, and this is something which is really new that we launched at reInvent as well, that you can have VPCs between regions now. Right. That means a VPC that will go over the Amazon backbone and not over the internet. So you don't have anymore to start your own VPN instances and make it redundant, go over the internet, encrypt. It's all done now on the Amazon corporate network. The second thing is what I said is those networks and those backbones allow us to do very interesting things like S3 cross-region replication. This is a service that is very important if you want to do failovers, multi-region failovers. Right. The S3 cross-region replication works as follows: is put data into my S3 bucket, and then there's an asynchronous replication of that data into another S3 bucket. And these are there's very interesting use case here because even if you don't want to have an active multi-region architecture, you can use that pattern to make sure you have a copy of your raw data and your customer data into another region, other account, far from anyone's access. Right? So when you store data into S3, it's a very good way to have a copy of that data somewhere else. And as I say, you can do the same in Europe with some of the data that you can replicate between regions or in the US there. The second thing, and this is unfortunately not serverless yet, and I'll explain why, but this is the way you can now do cross-region replication for read replicas on Amazon RDS. Amazon RDS is our relational databases, right? And now you allow to make a read replica into another region. So that means there's an asynchronous job that takes data from the master, replicate to another read replica into another region, and then you can do scenarios like this. That means you can do improve read latency for your users. For example, if they are sitting in Iceland, they can access a read replica that is in a region in Europe because it will increase the latency. Right? Now, if they really want to commit data into the database, they do have to commit to the master. Right? So this is a general common pattern as well to do multi-region architectures with RDS. So you have regional reads and then all the critical writes happening on the master there. But again, we talked about this latency. That means your application needs to support that. When you design global application, it's totally different paradigm because you need to understand that you won't have consistency necessarily between your users. Right? So you need to embrace that. And if you look the way Instagram, Facebook, all those global applications are working, they are totally embracing that. In fact, they are embracing that so much that it's very difficult to see from two people how things are so different. Right? They embrace that in the cache level, on the routing level, on the design level, on every level. Right? If you have that in mind, that your data is not going to be consistent, it sounds crazy like this to design an application like this, but at the end, when you embrace it from the beginning, it's not, and it gives you a lot of flexibility afterward. Right? You just need to think about it from the get-go, because if you start to design applications which are not embracing consistency or non-consistency, then it's quite difficult to come back. And something we just announced as well at reInvent this year is we are launching a regional multi-master, Aurora. And later in 2018, a multi-region multi-master, which will support multi-master on multi-regions, right? So it's going to be very, very interesting. And this is something that we support. So as I said, back in the days when we tried, and I worked on systems that were multi-regional with MySQL, for example, or Postgres, it's fairly difficult to maintain synchronization of data, especially the bin logs replication, make sure that they are consistent, right? Keep the tunnels up, have all these different links up and running, available and reliable. And here we're using the Amazon network, and the service will manage all that for you, right? So we'll replicate masters at the beginning to different AZs. So you will have multi-masters in different AZs, which you can hammer with reads and writes, and then also reads across all your AZs, right? And this is the way we've, because we orchestrated, or we designed Aurora that way, with a storage decoupled from the compute, right? So we are able to scale like that. And yes, a question. So in the region, at the beginning, when we're going to launch this multi-master on the region, is going to be synchronous. After that, multi-region, it can't be synchronous. So, but we're going to so it's going to be asynchronous with conflict resolutions and things like this. So they're very similar to what we do with DynamoDB. In fact, we just launched at reInvent service for doing just like on DynamoDB. But DynamoDB is our NoSQL offering. I guess now you probably heard about it quite often today. It's very highly scalable. It's serverless, so it sits across multiple AZ by default, and it's fully managed, so you don't have to worry about scaling it. And it's used across Amazon massively. In fact, just to give you a story, the Dynamo paper was written by Amazon. There's a white paper, a research paper on the Dynamo algorithm, and it came out as a measurement that we did on our website, Amazon.com, and we realized that 70% of the requests we were doing were not transactional. Right? So we had tons of databases, transactional database, not doing any transactions. So we moved into having a group of people thinking about, okay, how could we design a database at the Amazon scale, right? That could be highly scalable, all that stuff. And DynamoDB came out, right? So, but there's a Dynamo paper that actually received the award, ACM award. So a lot of database design have been based on that particular paper. Just to give you a little bit of metrics, because I love numbers, maybe you've realized. These are the metrics for the Prime Day. Prime Day is like the Black Friday, kind of specific to Amazon.com, where on one day we just give massive amount of sales that people can start buying stuff. And just to call out the DynamoDB numbers, it was handling and picking up almost 13 million requests per second, right? And handled in one day 3.3 trillion requests. So it's quite significant. And the fun thing is actually you can use it. So if your system, your company would scale to that size, you wouldn't have to do much to scale it. Just make an API request, create table, and we'll do the rest. So these kind of things that are pretty interesting that you can do. And as I say, we just launched now in reInvent what we call the global tables. And global tables is really about replicating a table globally. So you create a table in DynamoDB, and then you can globally replicate it to any other regions just by a couple of clicks. And well, all those things, very low latency because it sits on our corporate network, and it allows you to do very interesting failover scenarios or active-active scenarios. But I'll make a demo about it just at the end, just so that you have a sense of how easy it is to use. Another important features that we talked about a little bit before is DynamoDB streams. Is that everything that enters into Dynamo, we create a stream of activities that you can subscribe to, so, and then hook a Lambda function to it and do some, for example, data augmentation. And I use that architecture in the demo I'm going to do to collect data that is put into DynamoDB and do sentiment analysis and then restore the data into DynamoDB. So my API doesn't have to call sentiment analysis; is done in the database layer, kind of, which is very interesting. Another very, very, very important service, if you want to do multi-regions, is you need to have a DNS service. Right? Route 53 is going to be your best friend for that. It's our own authoritative DNS service. Again, it's highly available and scalable. In fact, we even say that we have 100% SLA, which is the only service we claim to have 100% SLA. Right? It supports what we call traffic flows, which gives you a variety of different routing combinations, from latency to regional failovers, and is very low latency and fault tolerant. The first the routing capability is the latency-based routing. So say that if you have two resources that are similar and in different regions, the resource will be, or the query, or the request, not the query, that will be routed to the lowest latency. Right? So if my end user is in Asia and this resource is in Asia, it means it's going to have a lower latency. So I'm going to be able to target the region, the resource that in the lowest region. And sometimes not necessarily the proximity. You can have actually lower latency, sometimes further. It depends on the congestion of the internet, right? So this is why it's interesting. So in that case, the traffic in green here will be routed to resource B. Then you have the GeoDNS, which seems that it should be the same as latency, but as I explained, sometimes it's not, because of the way the internet is routing, is that you can decide to orient all your users that are in EU to resource that sits in EU. That is very interesting use case for regulated service and things like that. Yeah? Especially if you want to have also geo-sharding, right? So very often when people design multi-region application, they have a sharding in the database. So a sharding is a way to organize data in the database, simply put like this. And what they like to do is organize by regions, right? So that they have an index for a particular region. So when a user gets into the service, is oriented to this database. It's easy to scale then database like that. So those GeoDNS and geo-sharding are usually working together, sitting together in architectures. There is also the weighted round robin, which is a classic of, right? We can go like this, round robin, but you can have a weight as well. So you can say 90% here, and then 1%, 10% here, right? So it will be able to route the traffic to those two resources. In the demo, I'm using a 50-50. Important thing to realize is when you test with your command line, it's very difficult to test round robin, weight round robin, and see you should have 1 and 1, right? The weight distribution happens at large scales when you have thousands or millions of users, okay? Something that is important to remember as well. Yeah, in that case, that's the way it happened. Then you have, lastly, the DNS failover. And this is a classic scenario, is that I route all my traffic first to resource A, and if something happened there, I shift immediately the traffic there. And this is very classic way of doing regional failovers. And it's a very good use case with asynchronous replication. So for example, with Dynamo global table as well. And as I said, a feature in API Gateway that allows us, or me, to do this demo today is that, otherwise I wouldn't be able to use that serverless, is regional API endpoint, right? Is that my API Gateway now supports regional endpoints. So that means I can have a domain name and then I have CNAME routing policies to regional endpoint. The only thing that needs to be supported by the regional endpoint is the custom domain name, so that I can have HTTPS all the way. I have the same certificate that is used across the way. Okay, so these are kind of the classic ways of doing. Now let's go into a demo, and this is what we're looking at today. Very simple way of doing it. We're gonna create first a DynamoDB table, make it global, see how it works, how the updates work, and then we have a Lambda function with API gateway, then use Route 53 to route the traffic, and we're gonna see that hopefully live. I don't guarantee anything. I don't have SLA like Route 53. All right, so let's first look at DynamoDB. I already created the table, but let's create one from scratch, because that's the when the fun and when things break. So let's create the I'll say, and that's a string. Yeah, cool. I don't add sort key. I don't want use default setting. Yeah. So create that. I have my DynamoDB table that's going to be created. Takes a couple of seconds. And here you see already we have a view on the stream, and this is exactly what I explained. Is DynamoDB supports streaming, right? And when we're going to do the replication, the global table it needs to have stream enable because it's using the streams. And now there's this little thing that came that didn't exist before, is this tab global tables. And what it tells you is that basically you need first to ensure DynamoDB streams are enabled, right? So I'm going to enable streams, new to old, that's it. So now my streams are enabled. That means every time I put data into DynamoDB, there's going to be data propagated to the stream. And now I can simply just add a region, right? So I have currently 5 regions supported for global table, Virginia, Frankfurt, Ireland, Ohio, and Oregon, and more will come over time. But let's say I'm in North Virginia and I want to replicate to Oregon. I'll just do like this. What it does is first creating the table in Oregon and then applying the settings, and then that's it. My table is created. I could go to table, but I don't want. I'll add another region. I'll say, let's say I want also my data to be in Ireland. So I can create as many regions as I want. 5 replication asynchronous. Pretty straightforward to do that. So let's now go to this table to see. This is the view of my table in US West, and you see I have the Day there, and with my global table here. That is. Okay, so it's the same that has been replicated between 2 regions. Okay. So let's look at the items, and if I want to create, let's say I want to show you how it works. So I'll create an item like so, test value, and then I will add let's say another string. I'm super creative, as you can see. And there I have my data that has been put into the table, and you can see if I look at my items, it's already been replicated in the regions, right? Now you can see I only added 2 fields, and DynamoDB by default added 2 fields. So one is the update region, the region that has done the update, and then the update time. So you see this one came from US East one. This is here where I did the update, so it's correct. So if I would create an item, say if I would create an item here, and I will add another string. I really need to improve my I need to go to theater, I think, to get this better, improve my my things. and you see your job was created. And if you look at where the data is coming from, it's coming from the west. So you've just witnessed asynchronous replication between very large to region, right? So I did exactly the same for that table. So you can see I already have a bunch of data in that table, but my Lambda function supports that, so I'll just use this. So we looked at those global tables. We've done that, yes. This is so that you can see in the slides when we're gonna distribute the slides. Now I'll show you a little bit the Lambda function, how it works, and how it's been deployed. I have a bit of time. So first we need to, of course, have a post. So this is my Lambda function. It's written in Python. Do you see everywhere? Cool. Tell me if you don't see. I'll just grow that stuff. And this is quite straightforward. It's not production-ready code. I'm sorry if it doesn't match your Python figure. It's respecting pip8, which I think is important enough for me. It's great. Silly. So this is my my Lambda function, and this Lambda function just it allows people to create some feedbacks, right? So what it does is call this function, which is just here, and it's pushing it into a JSON object, extracting information from the body of the request. I'm sending a body, which has a name score, session ID, session comments, some feedback ID, incognito ID that is taken automatically as well. All right. And then I push that into as an item into the table. So very simple way of using DynamoDB. And this is the way I initialize my connection. Here, something I just want to call out a little bit is that in Lambda, you have access to environment variable that you can get. So instead of hard coding the regions and say that I want my Lambda function to call US East, you either can get it like this to make your code very readable, or you can, if I would call a Lambda function DynamoDB functions without regions reference in the API, we'd automatically go to the one that is in the region of execution, right? But then your code is not necessarily readable what you're trying to do. All right, so these are the kind of things I'm doing. Then I just push that to Dynamo, and then I create a body object, and I return this. And you see, this needs to respect this format because API gateway, I'm using the proxy, Lambda proxy response, like template, right, which is the default for calling Lambda. All right. Then I've done the templates both in CloudFormation and in Serverless, but I'll show you the Serverless. This is how my service works. I have actually few functions. I have a post object. I have a get, so I can get an object as well. And then I have a health check here, which I check I haven't implemented my functions, but you get the idea. It's the demo, right? So my serverless is a framework to be able to deploy very fast API gateways and functions together, so I don't have to go in the consoles and things like this. So I have a service like this called global DynamoDB, tells my runtime, all this kind of stuff, my resources, the actions I allow for the policy to do. These are my package, because as I said in the previous talk, it's mandatory to bring your own libraries, right? So I have all my dependencies here that I want to include in my package, and then I have my different functions, right, which is get feedbacks, post feedbacks, and create feedbacks, and then get health. So then I can really be here and do an SLS deploy, for example, in my particular region. Do you see that there lower? This is how you invoke the so this is the way you would deploy your serverless application, right? So I can deploy it now, and of course then it will break everything. But if we don't try, And this is very nice way. This is why I love frameworks, is because they allow you to automatically deploy things very nicely, right? And this especially in terms of an API and things like this. And for me, having a function and definition of my API in the template is beautiful. Whether it's serverless, whether it's SAM, whether it's CloudFormation, either way, if you don't use any of those, you're doing wrong, right? So just pick one. I like serverless because I started with serverless and I'm just stupid and not to change too much. But I do have SAM as well. So when this works, it's going to take just a couple of seconds. You see it's already done. It gives me, it returns back all my API endpoints. So for example, here, then I can start to create feedback. So if I would do an, let me go on. If I would do an HTTP post, and then up, what the did just do? Then these are the things that I want to push in there. I have a feedback ID. This is my body, so the name, Lucky Luck 66, and that's my not my IRC name, not at all. Session score, this kind of stupid stuff. I'm sorry with the session ID. I need to change that. This is when I'm inspired. What it does is that's it. It sends the data in. It's terribly sorry. Did it go on the video really? We need to edit that. This returns the feedback ID that I can also get. For example, if I would do an HTTP get, and then what the heck did just happen? Yeah, I would get my feedback ID like this. And then it will return the JSON object that was stored in the DynamoDB table. And you see this one is the US East deploy because I did SLS deploy in US West, of course. Something didn't work well there. Maybe I had the wrong endpoint, but you get the idea. The framework should allow you to do this kind of stuff. So we have those. We've seen the Lambda functions. Now we need to look at the second things that you should do. Of course, you should deploy in different regions. So I've done here. So you would do US East 1 as well. So it gives you 2 API endpoints. So if you look at the API gateway here, I have my API gateway here called global DynamoDB with my three resources there that are created: create, get, and health. And then I have the same available in Ireland. All right. So basically now I have the setup where I have those 2 API gateways, Lambda functions, querying the same DynamoDB table. And you can look, actually, the DynamoDB table is a global table here, and then where I've been putting stuff there. Right? Okay. So there's data from pretty much everywhere. So let's take a look a little bit at Route 53, how that works. Actually, before that, I want to show you something which is important in API Gateway. When you are here, this is what you need to do. You need to create custom domains for your endpoint. And that means 2 things. That means you need to bring your own certificate. Here, I brought my ACM certificate called addon.me. It's actually the wildcard, so that you can do a bit more. And both API gateways need to have that. Right? So you can start querying them like that. And you see, there's also something else that's been created when you do a custom domain name. Is you get a target domain name. Right? So now you don't have the CloudFront distribution anymore in front with the so you have a target domain name, and this is going to be used by Route 53 to do, for example, health checking, and then other failovers. Okay. So let's take a look at Route 53. So this is Route 53. How it works, I'll show you there. This is my account. I have a hosted zone where I have my domain name there. I have tons of CNAMEs that are created. I'm not going to go through many of them. What is interesting to see here is that the global DynamoDB table is actually doesn't have a value. It uses traffic policy record. Right? And traffic policy record, you can access them like this. Whoops, sorry, traffic policy. I'll do this one. This is how it looks like. What you do is you have a graph of what's happening on your system. Here I have the start point, which is going to be my CNAME, and then I have rules, right? I have a weighted rule here that I apply to the policy, and what I'm saying is 50-50. I want the traffic to be routed to the endpoint, and then this is the target of the regional endpoint. Ideally, as I said, you should use a health check here, and I will enable them because okay, I lost my computer. Oh, there, man, you're following. Oops. So when I edit, it's creating a new version of that function, and then that. So I'll show you. You cannot use target health like this without having to create them. So we'll first create them. Let's keep that. Here are the health check. You can create health check. I've created 2 here, and those health checks are as follow: is that it's targeting this URL. You see the that URL is actually the URL in my API gateway that forwards the request to the health functions, and is simply it's used HTTPS and failure threshold 3. So if 3 requests fail, I will do a global failovers. All right? And here my global health is fine for both EU and US. So that means now I can do request like this with HTTPS, and then I can have my global. So you see my domain name now here. I can create my request with my domain name, and that will now be forwarded to round robin to them. So you can create this, and it goes to different things. So it's a very interesting use case because in fact, the latencies that I've observed, on the systems usually is below 150 milliseconds. So pretty interesting kind of use case you can do there. So this one was, for example, coming from the west and updated in the east at this time. So yeah, these kind of things you can do. Now let's see if I could break my Lambda function right away so that we can test the failovers. Oh, I'll update that one, for example, and say my feedback. No, how do I do? I need to do on the stage now. How could I change? I'll change directly. It's much faster for me to change the code. I'll check the health function, and I'll just say return 404. And then I'll deploy that in the east. So I've never tested this part yet. That's because I had the health check problem before, but it should be working. Oh, we're over time. Alright, so this is good. This is the last thing I want to do. So because it's gonna break anyway. But yeah, so we slowly managed to build a global DynamoDB table powered service like this. So in conclusion, it's really that's what we learned about. And basically what I want to say is, like, 5 years ago when we tried to do this in my previous company, it took 3 or 4 months of design and thinking. And this was built pretty much in a couple of hours. Just longest time was really thinking about how to name those variables. So what I'm just saying is there's tons of stuff that you can do. So think about this. The slide deck will be available, but the data consistency is very important. The application design, and understanding especially the nines of availability, right? And go serverless, at least at the beginning, because it allows you to scale without thinking of scaling first in the region, right? It gives you a lot of cool stuff. So please go build, folks, and have fun. Woohoo! And just to show you, after breaking my Lambda function, it still works. How was it, boss?